In section 11.9, we're going to multiply binomials containing radicals. So we're going to be looking at things that look a lot like the factoring sections. And we're going to be working with the FOIL method a little bit too. So I'm going to start out on page 544. I'm going to run through the examples and then some of the work problems also. So the first example, you've got 6 plus the square root of 11 minus, or times, excuse me, 6 minus the square root of 11. Now when you're working with this, this might look like a difference of two squares. If you remember back when we did like x plus 2 times x minus 2, when you FOILed this out, what you got was x squared minus 4. Now this is a similar situation. You've got the exact same first terms, exact same last terms, but they're opposite signs. Therefore, you won't have a middle term when you get done factoring this out. What you've got is 6 times 6, which is 36. Then you'll do 6 times negative square root of 11. So that's negative 6 square root of 11. Now come back to your second term. That's plus 6 times square root of 11. And the square root of 11 times square root of 11 is the square root of 121, which is 11. And that'll be negative. So you see right away these cancel out. You're left with 36 minus 11. So you're going to get the numeric answer of 25. So use that difference of two squares knowledge that you got to help you speed that process up. Now example 2, what you got here is a perfect square. And to kind of show you again what that is, based on what you've done in the past, you had x plus 2 squared before, and you called that a perfect square. And what that meant was the binomial times itself. And it always helps to write that out in parentheses. Because a lot of people make the mistake of just doing x squared plus 4, and that's not how you do that. Now when you FOILed this out, you did x times x, x times 2, 2 times x, and then your last term was 2 times 2, which is 4. And you had these middle terms combined. Now, the point of that is that you've got a middle term here of 4x. So you're going to have the same situation over here. You've got 3 plus the square root of 5 times another 3 plus square root of 5. And when you FOIL it, you get 3 times 3, which is 9. 3 times the square root of 5, which is 3 square root of 5. Another term exactly like that. And then the square root of 5 times the square root of 5 will give you the square root of 25, or just 5. So you're going to combine these middle terms, so your answer becomes, and let me do this in the same step, 9 plus 5 is 14. So let's do 14 plus 6 square root of 5. Remember not to add up the 5s when you add these together. You're just adding your coefficients of 3 and 3. And you can also write that 6 square root of 5 plus 14. Just make it really obvious that your radical symbol stops after the 5. And there's not one that's better than the other. So you can answer in either format. Example 3, still on 544. I'm going to use the same recommendation here. Write this out. That way you don't have a tendency of just squaring your first and last term and you're done. So do 2 times 2, which is 4. And here's where it gets a little bit trickier. There's an extra step. Some of you will do it mentally, some will need to do it on paper. But you're going to have the square root of 3 times square root of 3 also times the 2 times 2. Well, the square root of 3 times square root of 3 is 3. So you can do 4 times 3. Or if that doesn't make sense, do the square root of 3 times square root of 3 of that term. And make that the square root of 9. Alright, so I got that from this operation. Let me just put all those in parentheses there. Alright, so 2 times 2 gave me the 4. And the square root of 3 times square root of 3 gave me the square root of 9. The square root of 9 is 3, giving me 12. Alright, the next thing I'll do is 2 square root of 3 times negative 5 square root of 7. So I'm going to have negative 10 square root of 21. And I can't break that down, so I'm just going to go ahead and write that into my next step. Notice I'm doing two steps at once here. Now I've got negative 5 square root of 7 times 2 square root of 3. Well, that's identical to what I just did. So this is another perfect square. And my last term is a negative times a negative. So that'll give me a positive 25 square root of 7 times another square root of 7. Now that would be 25 times the square root of 49. Square root of 49 is 7. So 7 times 25 gives me 175. Combine like terms. You've got 17 here. A positive 175. That gives me 187. Negative 10 minus 10 more gives me negative 20 square roots of 21. And there's how you arrived at your answer. This is the part where you're going to get the most confused. Because when you're doing like those last terms, this is the last set, you had a negative 5 times the square root of 7 that you're multiplying by another negative 5 square root of 7. So just to run through one more time. Do your negative 5 times negative 5 and get 25. Now it's up to you as to how you view it. Pick what works best. If you do square root of 7 times square root of 7, you could make that the square root of 49. And then take the square of that, which is 7, or the square root of that, which is 7. Some of you will instantly go to 7 at this step, and that's perfectly fine. All right, example 4. Now in this, you're rationalizing the denominator again, doing something called a conjugate. And what I'm going to do is show you how to rationalize when it's a binomial. What you're going to use is the conjugate of 5 minus 2 square root of 7, which is 5 plus 2 times the square root of 7. And just like we rationalized denominators before, I'm going to do the same thing on the top and bottom because I'm multiplying by 1. So I can do that. All right, what this creates is we pull the bottom part of this out. I have 5 minus 2 square root of 7 times 5 plus 2 square root of 7. Now back in our previous example page, right here, example 1, that's where our middle terms canceled. That same exact thing is going to happen right here. I don't have a middle term to worry about. I have to worry about 5 times 5, and I have to worry about the 2 square root of 7. So 5 times 5 is 25. Negative 2 times 2 is negative 4. And it's going to be times 7. 4 times 7 is 28. So underneath, I'm going to have a negative 3. On top, I'm going to have 3 times 5 plus 2 square root of 7. Now, the reason I didn't distribute that out is because I already discovered I had a 3 on the bottom. And that is going to cancel. When you have a negative sign in a denominator, you can't stop. You have to make that go up to the top. You're essentially multiplying the top and bottom by negative 1. That makes it negative 5 plus 2 square root of 7. And simplified even better is negative 5 minus 2 square root of 7 as your answer. So that conjugate is what's going to make this possible for you. Again, you're going to see this on placement tests and, of course, tests. So that's important to know. And you'll see that again in a couple moments. All right, problem from the assignment, number 12. The way I'd like to see you work this is to write it out fully. Otherwise, you're going to have a tendency of just squaring the first and last term. And since this is a perfect square instead of a difference of squares, you will have a middle term. So you have 3 square root of 7 times 3 root of 7, square root of 7. That's going to be 9 times 7, which is 63. Or 9 times the square root of 49. And then pull your 7 out. You're going to have 3 times square root of 7 times negative 3. So that's minus 3 square root of 21. And you're going to have that twice, since this is a perfect square. Your last term is a negative times a negative, turning it into a positive. The square root of 3 times square root of 3 is the square root of 9, or just 3. So your last step is to simplify like terms. 9 times 7 is 63. So I'm going to do 63 plus 3, give me 66. Negative 3 minus 3 more is negative 6 square roots of 21. And that is, that's all you need for this one. All right, number 27, we're back to using a conjugate again. You have 2 minus square root of 7 underneath. Now remember, these are all locked into parentheses, so if this helps, I can't just multiply by a square root of 7. I could if it was 2 times the square root of 7, but since it's 2 minus, I can't break that up yet. So I multiply the top and bottom by the conjugate, which is 2 plus the square root of 7. And again, recognize these as difference of two squares. The square root of 7 times the square root of 7 is going to be 7. 2 times 2 is 4. So here's how I'll do that. Underneath, I'll just drop down and perform that function, giving me a negative 3 at the bottom. Now on top, it's not a difference of two squares anymore, so be careful of that. I'm going to do 1 times 2, and then I'm going to do 1 times the square root of 7, which is just square root of 7. Right here, I have 2 times the square root of 7. Extend this out a little bit. And then the square root of 7 times the square root of 7 is another 7. So my last step is just to combine like terms. Well, it might be my last step. I don't know that yet. I'm going to do 2 plus 7 is 9. And I have 3 square root of 7 total. All right, so that wasn't my last step, because I can take negative 3 out of both of these terms. That negative 3 is going to affect the 9, and it affects the positive 3 due to those unseen parentheses that are there. 9 divided by negative 3 is negative 3. 3 divided by negative 3 is negative 1. I don't need to put the 1, so there's my answer, negative 3 minus the square root of 7. Let me show that one alternate way real quick. The other thing you can do is factor a 3 out on top, which would make that 3 plus the square root of 7, and put that under the negative 3, and then cancel right there. Again, the negative must move up here. And if you distribute negative out to these terms, I will get the answer we have circled here. Just in case this is messing with you in this step right here. Okay, that's it. No, it's not it. Oh, one more. Then it's it. All right, so number 33. Another conjugate situation. 2 square root of 5 plus 3. 2 square root of 5 plus 3. Okay. Underneath, I'm going to have 2 times the square root of 5 times 2 square root of 5. It's going to be 4 times 5, or 20. Then I have negative 3 times positive 3, which is negative 9. So my denominator is going to be 11. So I did all of that first so I can see if anything's going to cancel, possibly. Of course, it doesn't make much difference on this one. We don't have a difference of two squares or a perfect square up here. So I've got to start out with 4 times 2, which is 8, square root of 5. Now 4 times 3, which is 12. I'll go back here. I've got 2 square root of 2 times 2 square root of 5. That's 4 square root of 10. I'm going to just mark that out and keep going. And now 2 square root of 2 times 3 gives me 6 square root of 2. Alright, in this situation, it looks like not a single thing can cancel, so we just have a very long answer. So yeah, we're just ready to rewrite at this point. Order does not make very much difference. So 8 square root of 5 plus 12 plus 4 square root of 10 plus 6 square root of 2 all over 11, and that's as far as you can go. So avoid the common denominator type thought or common multiple. When you see the 2 and the 5 and the 10, you cannot adjust that. There's no mathematical way of creating those to be equal at this stage. All right, and that's where you're at. Okay, now we're done. Now we're finished. There's one more video in chapter 11. That's 11:10. You're working with solving equations. And after that, that is the end of chapter 11.